In this lesson, you will learn about straight line equations, parallel and perpendicular lines. Start a new document and insert a graphs application. We are going to be plotting points and drawing lines. To keep the points as whole numbers, we can display a dot grid. Press Menu, Settings, and tab down to Grid, and select Dot Grid. Then press Enter. Let's start by drawing a line. Press Menu, Geometry, Points and Lines, and select Line. Notice that our cursor has changed to a pen. Place the cursor over a point on the grid and click. Now place the cursor over another point and click. Then press Escape to release the line tool. What's the equation to our line? To see the equation, move the mouse over the line, press Ctrl followed by Menu, and then select Coordinates and Equations. With the mouse over the equation, click and hold. This grabs the equation. Now move it to the top left corner of the screen and press Escape. We can select either point A or B and move the line. Notice that the equation automatically updates. Suppose I want to create a line parallel to this one. Press Menu, Geometry, and then Construct, and select Parallel. Move the pen over a point on the grid and click. Now point to the line and click. We now have a line passing through our new point that is parallel to the original line. Now let's have a look at the equation. We can drag one of the points on the original line to see how the two equations are related. We can also move our point on the parallel line to a new location, and the line will always remain parallel. Notice that the slope of each line appears to be the same. Now let's delete the parallel line, not the point, just the line. Move the cursor over the line, press Ctrl followed by Menu, and select Delete. We can see that the slope is key when it comes to parallel lines. We can use the Geometry tool to measure the slope or gradient of the original line. Press Menu, Geometry, Measure, and select Slope. Now click on the line. The slope measurement is attached to the mouse. Move it off to the left and click. Press Escape to release the slope measuring tool. Now place the mouse over the slope measurement and press Ctrl followed by Menu. We're going to store this slope in a variable. Select Store. Delete the default variable name and then use the math templates and select the subscript tool. We'll store the gradient as M1. Now hover the mouse over the point, press Ctrl followed by Menu, and get the coordinates of the point. And just like the slope measurement, we'll store the coordinates as x1, y1. Now suppose we want to define the equation to a line, parallel to our original line, passing through point C. Press Tab and type in the equation m1 times x minus x1 plus y1. This is a translational form of a straight line. Move the original line. Notice that our defined equation remains parallel. We can also move point C and see that our line continues to remain parallel, passing through point C. Now let's explore perpendicular lines. First, I'll delete our parallel line. We can use the geometry tools to construct a line perpendicular to our original line passing through point C. We'll measure the slope of our perpendicular line. Now let's move the original line. Notice that if the original line has a very steep slope, the perpendicular line has a very small slope. Also, if the original line has a positive slope, the perpendicular one has a negative slope. Let's try a calculation. Press Menu, Actions, and select Text. Now we can type an expression. We notice that the perpendicular line has the opposite sign to the original. So we'll start by typing a negative sign. We also notice that the relationship appears to be a reciprocal type arrangement. As one goes up, the other one goes down. So let's write 1 over m1 and press Enter. To calculate the expression that we've just typed, press Ctrl followed by Menu. Select Calculate. We could choose the value for m1, however, it's already been stored, so I'll press L to link the calculation to our stored value for m1. Now let's move the original line. Our calculation appears to be the same as the gradient of the perpendicular line that we constructed. I'll delete the perpendicular line, then press Tab to enter an equation. And I'll define the equation as -1 divided by m1 multiplied by x minus x1 plus y1, our translational form of a straight line. Now we can move our original line. Or point C, and see that our defined equation is always perpendicular to our original line and passing through point C. So, to summarise, parallel lines have the same gradient. Perpendicular lines have a product of their gradients equal to -1.